So today's target is I can calculate density. Have you ever been asked what weighs more, a pound of feathers or a pound of lead? And I think you may be fooled if you say, oh, lead for sure, right? The answer is a pound of feathers and 1 pound of lead weighs the exact same. But we often confuse density. We know lead is more compact, whereas feathers, there's like this airy space if they were packed into a box, for instance. So we often can easily confuse density with weight. They are totally different. Density is how compact or compressed a substance is. So I love this visual. These two objects are equal in volume, but different in mass due to their density. So if you see right here, this could be the lead and this could be the feathers. Density is also what makes an object float. So something that's heavier like lead would sink to the bottom, where something like a feather that has that air pockets in it would rise to the top. So to calculate density, you divide mass by volume. And I know you're thinking, oh gosh, that's just one more formula to memorize. But on the air test, it's kind of nice. There's always one of these, and they will, for example, give this problem. A block has a mass of 325 grams and a volume of 500 centimeters cubed. What is the block's density in grams per centimeters cubed? So they may have grams per centimeters cubed. And that flat out tells you what to do. It says, hey, put the grams on top and the centimeters cubed on bottom and simply divide it. So, you really don't need to memorize a formula if you're able to take those, see that clue and just divide what it says. So what I'm left with is 0.65 grams per centimeters cubed. Okay. Now, some are a little harder. Some might have you convert units. So meters, liters, grams. You might be working with the metric unit. So, you may have heard this in grade school. King Henry died unexpectedly drinking chocolate milk. I really love this because if, for example, I was given, 0.625 milliliters and I was asked to convert it to liters. This chart, and honestly on a test, I would just dump out King Henry died unexpectedly drinking chocolate milk. I just drop out the letters. And then what I can do is start at milliliters and move left 1, 2, 3 to units because I know that's where liters, meters, grams are. And since I move left 3 there, I will move my decimal place left 1, 2, 3. So 0.00065. If let's say I have, 25 centimeters, and I ask you to move that to kilometers. So from centimeters, that's left 1, 2, 3, 4, 5. So my decimal would go left 1, 2, 3, 4, 5. The same thing works backwards. So for example, if I had, let's just start here. 2020 kilometers. And I say, okay, how many meters is that? Well, I would move 1, 2, 3 to the right. So I would move my decimal 1, 2, 3 to the right. In this case, I'd have to stick in some commas there, and that's how this works. So Really great chart, really great way to convert units. So why am I telling you this? Well, if I say calculate the density in grams per milliliters of aluminum if a 50 milliliter block weighs 0.13 kilograms. So I'm going to dump out King Hector dies unexpectedly drinking chocolate milk. And I'm going to take these kilograms right here, 0.135, and convert them to grams. So I'm going to first count. I'm going to say, okay, that's right. 1, 2, 3. So I'll take this right. 1, 2, 3. So what was 0.135 kilograms is 135 grams. Now to calculate the density in grams per milliliter, again, that's your dead giveaway. We don't need to memorize a formula because it tells us, hey, put the grams on top, put the milliliters on bottom, and then just divide it. So I'm going to just do 135 divided by 50, and I get 2.7 grams per milliliter. Okay? What if this is a spot where I'd love for you to pause it and try to calculate the density of cotton candy. Go ahead. All right, did you get 10 grams per liter? On that one, you had 2 conversions. You had to take 0.03 kilograms to grams, and that was a movement of 3 to the right. So we took that decimal, moved it 3 to the right to get 30. You did have to do a filler. So if you move it and there's nothing there, you have to put a 0 in. And then we had to also change our milliliters to liters, and that was a 3 to the left movement. So I moved that 3 to the left to get 3 liters. And then again, the gram per liters was a real dead giveaway. I put the grams on top, the liters on bottom, and then I divide, okay? Another thing that Air Test likes is you working backwards from density. So it says Lancaster, Ohio has a population density of 2,122 people per square mile. So again, there's a dead giveaway of what we're going to do. If there are 40,159 people in Lancaster, what is the area in square miles of Lancaster, Ohio? So this is 2020 data. But because it's people per square mile, that's what it tells me, and that's the population density. Again, there is no memorizing formulas. I am just looking at my clues. Okay, now I'm going to plug in population density is 2,122. The number of people are 40,159. And it says, what is the area? Do you see what I did? Without having really zero knowledge of what population density is, but I was able to do this problem. But just to let you know, population density is, again, how many people are packed in per square mile. We've seen this before with trig. If the variable's down low, switch them, So the x pops and the 2,122 drops. And now I'll just divide that. So 40,159 divided by 2,122, and I get 18.9 people. I'm just joking. This is the area, so that would be miles squared. Okay? So very cool. We just calculated the population of Lancaster working backwards. So hopefully this lesson gave you a good idea of what density is, but also let you see that a lot of these density problems, it's just reading and using the clues to tell you exactly what to divide to get there.